Hey guys, today we're going to show you the installation that we did about a month ago for a battery monitor. It is the BMV-712 made by Victron, and it is Bluetooth capable, which is really nice because we're able to connect to it directly via our smartphone and the Victron Connect Bluetooth application. We're going to show you the installation of the battery monitor as well as some of the particulars that went into it, because we have a Battleborn lithium iron phosphate battery, so some of the settings are a little different than lead acid or AGM batteries. Show you some of those particulars, and we're also going to give you a review at the end of the video for our 1 month of use with the battery monitor. You may be wondering, why would I even want or need a battery monitor? Well, for us, there are multiple reasons. So if we're not plugged into shore power at an RV park, if we're out boondocking or dry camping, we're going to want to know exactly what the state of charge is of our battery. To determine the state of charge, we do have in our rig, we have a monitor that was installed by the manufacturer that shows the voltage. To try to determine the state of charge using the voltages found on the display, you would then need to download a chart that you can find online, depending on what battery you have, whether it's lead acid, AGM, or lithium, and then use that chart to make that determination. And if you have ever looked at these charts, they vary widely in percentages from one voltage to the next. So it is very difficult to determine the state of charge. One of the other main reasons that we want to install this battery monitor is I want to find out, whenever we're boondocking or dry camping, how much power we're consuming whenever we're running lights or appliances throughout the day. And I also want to know how much power we're putting back into the battery whenever we're running our generator. And I'm actually going to put together a solar suitcase here real soon. I have all the components, so I'll be building that soon. And I want to know how much power I'm putting back into the batteries with that solar suitcase. So those are the main reasons why we have this battery monitor now. Here is the battery monitor, brand new in the box. You get a quick installation guide, a manual. You'll have several wires here for the positive connections. We're only going to use one of these today. This is a UTP cable. We're going to mount the monitor inside another section over near the battery. Here is the shunt that comes with the unit. Here is the monitor itself. This is a bezel that goes with the monitor. We're not going to use that either, and we're not installing it in the wall in our RV. I also had to purchase some extra positive and negative cables. I'm actually going to only use the negative cable. For my particular RV is a 6 AWG cable, and we need that to connect the shunt to the battery, so we need an extra cable there. One other thing we're going to need today too is a couple extra screws to install the shunt. They don't provide those screws for some reason, so we're going to install this shunt near the battery, and I have a couple extra screws that I'll show you whenever we do the installation. So what a shunt is it's a resistive element with two conductive metals on each side, and then there's a strap of alloy metal called manganese in between that creates a low resistance path for the electric current to flow through while still allowing it to be sampled in either volts or amps. Now, from my understanding, most manufacturers don't install shunts in their RVs. I know ours didn't, and that in turn will not allow for an accurate reading from the battery monitor. So here's the quick start guide. This basically gives you the blueprint for the installation of the monitor, as well as some diagrams on how to hook up the shunt to the battery. Again, we're not going to use this section because this is the in-wall installation for the monitor itself. The other part of the guide here shows you the shunt with the different connections. You also have a note here, connect the negative pole of the battery last. So very important for that. There's different connections here. One is for a starter or auxiliary battery. So if you have a secondary battery, like in your vehicle, if you have a Class A or B vehicle, and you have that starter battery, then you can connect and monitor that through the system. This is not going to apply to us today, so we're not going to use that part of the diagram. Down here you have also a diagram for temperature monitoring. So there's a temperature sensor that you can purchase separately. We don't have that. I may purchase that in the future just to have that, but you would connect that to the shunt and the positive part of the battery there. This part of the quick start guide gives a diagram for 24 volt system. We don't have that. We have a 12 volt system here in our rig. But yeah, this will have a diagram for midpoint voltage monitoring and without midpoint voltage monitoring for 24 volts. And then they have the same thing on the back here for 48 volt. So what we're going to need today for our installation is the battery shunt, the monitor, the UTP cable, only one of these positive leads, and then the one extra negative cable. I just wanted to stop here and take a second to talk about wire sizing for a minute. Every RV is going to be different, and whenever you're either adding or changing out wiring in an RV, you got to make sure that you're getting everything exactly right. So if you're unsure at all, you definitely need to contact a professional and or the manufacturer to make sure that you have all the right information and are going to be using the correct size and type of wire. You never want to undersize your wire, or you could run into an issue where you're going to have a dangerous situation where it could actually cause a fire. So be very careful with that. And like I said, always make sure you know what you're doing when you're doing anything with wiring. So here's the battery shunt. And this side over here where it says battery only with a negative sign there, that's going to get connected directly to the negative side of the battery. This side over here is also negative, and a negative wire will get connected to the house load. So it says load and charger right there. This connection here is for the UTP cable that runs to the battery monitor, and these two connections say B1 and B2. B1 gets connected to the positive side of the battery. B2 would be used for either a temperature monitor for the main battery, or you can also use it for a house battery if you have a Class A or Class B to connect to the starter battery. That's everything as far as the parts go, so let's go ahead and get it installed. Okay, first things first, disconnect the battery at your battery disconnect switch. Alright, so here's the battery. The first thing you want to do always is take the negative terminal off first, and then take the positive off. These were the three wires that were connected to my negative battery terminal. This one here is from a tire pressure monitoring system that I have installed. This one here comes from the solar setup that came with the RV. And this other one here is the ground for the house. I'm going to use this ground to connect to the battery monitor that's already connected to a ground back here in the back. That's the ground for the house right there in the back. So on this side, I have the positive lead that goes to my tire pressure monitoring system. I have a positive lead for the integrated house solar system, and then the positive lead for the house itself. Right here you can see for the connection for B1, which is what I'm going to connect first just to make it easier. I'm going to connect the wire in there. You have to push this tab back right here in order to then insert the wire into that small hole, and then that'll grab the wire. Alright, so we're back again several days later from where we just were. Found out the hard way that I ordered the wrong product. It was the right gauge wire, however the lugs were the incorrect size. So I ordered a 5/16 inch lug and I needed a 3/8 inch lug. Pretty big difference there. How I found that out, I would have been fine on the battery, however the lugs up here for the shunt are quite a bit larger, as you can see here, compared to the actual battery lugs that I have. So don't make that mistake. Whenever they sent me the wire, they sent me a 2/0 gauge wire, which was way bigger than what I need. However, if it's going to be a difference there, you want it to be, the cable to be larger rather than smaller. You can see the cable size is much different, but this should work perfectly fine. We're going to get this installed now. So I've got my new battery cable here that's connected to the battery side only of the shunt. I will be connecting this, but per the instructions, we need to first connect the positive side, and then the negative side is last. So I'm going to remove this fuse first, where this positive lead is connected to the shunt. We'll reinstall that afterward. And then I'm going to take my 3 wires I had previously connected to the positive side. We're going to reconnect those, and we're also going to connect the new wire that runs to the shunt. We have these washers as well. These are helpful to get a good connection. Use those washers before you put the nut on. So now that the positive connections are all made, again on the battery, we're going to go ahead and connect the negative side. Once again, always want to do that last. The only thing we're going to connect on this terminal for the battery, the negative side, is going to be the wire running to this side of the shunt. So that's the only thing that gets connected here. These other 2 wires that were connected to the battery here are going to be connected up here on the top side of the shunt. That way we're isolating the battery completely to this side of the shunt. So now you can see that I've connected the other 2 wires that I previously had connected to the negative terminal of the battery up here to the top side of the shunt. And then this wire here runs down to the ground located here on the house itself. So here's your UTP cable. We're going to connect that to the shunt right back here. Just going to connect it in right now, and it's not going to turn on until I put that fuse in this positive lead, which I'm going to do now. And there it is. So you can see here that all I did to kind of secure this in place was put a zip tie around the wiring here, and I have this here nice and tight with the wires, so it's not going to move as we're going down the road. Maybe a little bit, but not much. So that's all I'm going to do with that, because we don't really need to use this display. We're going to use the Bluetooth. I'm currently downloading the Victron Connect app. Once that's downloaded, installed, I'll be able to connect to the BMV-712. Would you like to use Bluetooth? Yes. So device list. Through this page you can see all the nearby Victron products you can connect to. So we're going to connect to that. Hit device list. There it is, BMV-712. It's connecting. Bluetooth pairing request. Should be 6 zeros to pair. There it goes, it's connecting. Click on the device. Recommend that they change the pin code. So we're going to change the pin code. Pin codes are changed. We have a lithium iron phosphate battery. Battleborn 100 amp hour. And they recommend, if you have a lithium ion, to change a couple of the parameters. One being the charge efficiency should be at 99%, and then also they recommend setting Peukert's exponent at 1.05. So we're going to do that. Back at the main screen here, click the icon up at the top, right up here, this little gear icon. And that's going to take us to the next screen with battery, relay, alarm, etc. We're going to click on battery, and then we're going to click on Peukert exponent. It's currently at 1.25. We're going to change that per the recommendation to 1.05. And then the charge efficiency factor is currently at 95%. We're going to change that to 99% per the recommendation. So I do see here that we have the battery capacity at 200 amp hours, which is not correct. We want 100 amp hours for our battery. So now we are at 100 amp hours. All right, so we're back here in the comfort of home, and we can do that because we have the Bluetooth app. So pretty cool. For our battery, I had to look up online for the lithium ion battery. The max charge voltage is going to be 14.4. Charged voltage is currently at 0.0. So we need to change that to 14.4. So the next thing we're going to look at is the discharge floor. And it currently is set at 50%, which is typical for a lead acid battery. But being that we have the lithium battery, go on to Battleborn's website. The question is, what is the depth of discharge and how does it affect the battery? So this is the great thing about lithium batteries, is they can be discharged continually to 100% per Battleborn. And it says you can expect to get 3,000 life cycles out of this depth of discharge. So we're going to go ahead and change that to 0 for the depth of discharge floor. Okay, so fortunately for me, anyway, with this Battleborn lithium ion battery that we have, I was able to go and find a video that they did specifically for the settings for the Bluetooth monitor. I was able to go through and get all the other settings for tail current, charge detection time, the Peukert exponent, all that stuff is all in there in this video, so made it easy. So not sure if your battery manufacturer that you're using will have the same information available, but Battleborn did a great job in that respect for this. So, but yeah, I don't have explanations for the rest of the settings, such as like the charge efficiency factor and the current threshold and all that. But I'm just going to run with it and go with what they recommended. So the one thing I noticed is that whenever I changed those other settings, it automatically changed the discharge floor to 5%, which I had it at 0% before. I'm just going to leave that there. I'm assuming that's going to be something that we'll want to leave as is. All right, doing a little more research, found the battery capacity that was previously stated by Battleborn to be 99 amp hours. I guess that is an outdated number. And the amperage capacity should be set to whatever the total amp hours of your entire bank is. This will allow for the correct calculations for the BMV. So the 99 amp hour was an old measurement from previous batteries. So I'm going to change this back from 99 to 100. I should note here too, just to make sure there's no confusion, on Battleborn's website. For anyone that does have a Battleborn battery, their video is how to configure Victron BMV-712 with Bluetooth dongle, and the manual that you receive with your BMV-712 is also for the BMV-700 and the BMV-702. So this will be compatible with your battery. Alright guys, we've been using this battery monitor for about a month now, and so far it's great. We love it. You know, it's very nice to be able to just pull it up on your phone, be able to see the state of charge at a percentage versus going and looking at our monitor that just shows voltage. So we can actually see, you know, is it 80%, 90%, where are we at with the state of charge. It's nice being able to see how the current is either going out of the battery or coming into the battery if we're charging it. It also shows the power either coming in or going out in watts. We have consumed amp hours as well, which kind of coincides with the percentage of state of charge. I also have the temperature monitor installed now, so I can monitor the temperature. The Victron battery temperature monitor does not come with any instructions. Found out that the original red lead that came with the BMV-712 that has the fuse in it that runs from B1 on the shunt down to the positive connection on the battery gets removed completely. Then you install the new leads from the temperature monitor. The red gets plugged into B1 on the shunt. The black gets plugged into B2 on the shunt. And then there is one connection to the positive on the battery. Another cool feature that I really like is the battery monitor and shunt have a relay on it where you can set different parameters where, say, the temperature gets too hot or too cold. It will shut down the current either being discharged or input into the battery in order to protect it. Same thing goes for voltage. If the voltage drops too low or if the voltage goes too high, you can set the relay so that it shuts off the current going in and out of the battery. A couple of the features of the app that I don't think that I'll use a whole lot are the history tab and the trend tab. Just probably something I don't think I'll really look at a whole lot. A couple useful features on there, such as the deepest discharge of the battery or the cumulative amp hours withdrawn from the battery. That might be something I look at periodically, but I'll probably just mostly use that front screen where it has the state of charge and all the other main features there. To conclude, I would have to say that we're very happy with the performance of the battery monitor, and the ease and convenience of the Bluetooth app is great. We also love the fact that it's very reliable and accurate. We could highly recommend this battery monitor. If you want to pick one up, I know you can pick them up on Amazon and other outlets, but if you do pick one up, I would definitely recommend that you get the BMV-712 model. The other models, the BMV-700 and 702, do not have the Bluetooth built in. You would have to buy a Bluetooth dongle in order to connect to the Victron Connect App. So the BMV-712 is definitely the way to go in my opinion. So, well, hope this video helps out and hope you enjoyed it. We'll see you next time.